All right, hi folks, I'm recording a video here from section 4.3. This has to do with rational functions. And I wanted to show an example of how to determine both vertical and horizontal or oblique asymptotes. Now, in some of the previous examples, we found vertical and horizontal asymptotes by looking at the graph. And in those graphs we were looking at, there might have been a vertical red dashed line that the graph did not cross. That was the vertical asymptote. And we also noticed there was a horizontal red dashed line. That was the horizontal asymptote. But how do you determine the vertical and horizontal asymptotes if you're just given the function, not the graph? Well, let's take a look at this example here. It says find vertical, horizontal, and oblique asymptotes for this rational function. They're giving us of 17x over x plus 10. All right, let's find vertical asymptotes first, then we'll find horizontal. Let me come over to the right-hand side here. I wrote down a comment. It says to find vertical asymptotes, first eliminate any common factors that might exist for numerator and denominator, and then set the denominator equal to 0 and solve for x. Well, in my example, there's no common factors for the numerator and denominator. So I'm just going to go ahead and set the denominator equal to 0. So I'm taking this denominator and setting the denominator equal to 0. Well, now I'm going to subtract 10 from both sides, so that gets me x equals negative 10. Well, that's the vertical asymptote. Now I know x cannot equal negative 10 in this function, because if I did plug in negative 10, the denominator would be 0, and of course I'm not allowed to divide by 0. So it makes sense that there's a vertical asymptote at x equal negative 10, because x is not allowed to take on the value negative 10 for this function. If I was going to draw this, I would be drawing a vertical line at x equal negative 10. Maybe that's back here somewhere. So this vertical line is the vertical asymptote. Okay, and remember, the graph would not cross this line. It would get closer and closer to that vertical line, but never touch that vertical line. All right, so the answer to this one is there's one vertical asymptote at x equal negative 10. By the way, notice it says type an equation, so I can't just write negative 10. For the answer, I have to have an equation, and that's x equal negative 10. All right, let's go to the next part. It says, what about horizontal asymptotes? Well, for horizontal asymptotes, things get a little more complicated. So let me go to page 203. And page 203 is trying to give you a set of guidelines on how to know about horizontal or oblique asymptotes. And the key here is to compare the degree of the numerator and the degree of the denominator. Okay? So look at the top of the fraction, figure out the degree on top. Look at the bottom of the fraction, figure out the degree on the bottom. Then you compare. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is a horizontal asymptote. Well, y equals 0 is the x-axis. So this is saying that the x-axis is a horizontal asymptote. Let me give you an example. Let me come up with an example for that first scenario. Okay, let me call this condition A. So let me come up with a function for condition A. Maybe I have f of x equals, now remember the degree on the top has to be less than the degree on the bottom. So maybe this would be 7x to the third plus 2x over 6x squared minus 5x. Notice the degree on top is 3. And the degree on the bottom, oops, I have to make the numerator less than the degree. So I better make the denominator be a higher degree. So I'm going to make this a degree 4. Let me change that. So I'm going to write this as 6x squared. I'm sorry, 6x to the 5. So the degree on top is a 3, and the degree on the bottom is a 5. So notice the degree on top is less than the degree on the bottom. So this graph would have a horizontal asymptote equal to the x-axis. All right, let me go to example B here. What if the degree on top is equal to the degree on the bottom? Let me give you an example for scenario B. How about if I had a function like y equals, actually I'm going to use our example, 17x over x plus 10. So again, I want to compare degree on top with degree on bottom. Well, the degree on top is 1, the degree on the bottom is 1. So the degrees are the same. It says the line y equals a sub n over b sub m is the horizontal asymptote. What they mean by a sub n is the leading coefficient on top. Well, that's 17. And what they mean by b sub m is the leading coefficient on the bottom. So what they're telling me here is the horizontal asymptote is going to be 17 over 1, which is just 17. So if I was going to graph this way up here at y equals 17, that would be a horizontal asymptote for this function. Okay. It says, what if the degree on top is 1 more than the degree on the bottom? So let me give you an example for scenario C. That might be a function like y equals 5x to the 4 plus 2x over 7x to the 3rd minus 6x squared, let's say. So notice the degree on top is a 4, the degree on the bottom is a 3. So it says if the degree on top is 1 more than the degree on the denominator, then this is going to have an oblique asymptote. So this would have an oblique asymptote of some kind. Remember, that means the asymptote is going to be a slanted line, maybe something like this. All right, one more. Let me go down here to the bottom. It says if the degree of the numerator is 2 or more greater than the degree of the denominator, then there's no horizontal asymptote. So let me draw a scenario for D. How about if we had something like 15x to the 6 over 3x to the 4. Well, the degree on top is 6. The degree on the bottom is 4. Notice the degree on top is 2 or more greater than the degree on the bottom. So that means there's no horizontal asymptote here. What that's telling me is the graph maybe is, let's say, increasing like this. Notice there's no horizontal or vertical asymptote. So this answer for this question is going to be there is one horizontal asymptote. We worked this out over here. It was y equals 17. Then it's going to ask, what about an oblique asymptote? Well, in ours, there is no oblique asymptote. Remember, the oblique asymptote would only be if the degree on top is 1 more than the degree on the bottom, but that's not what we have here. So this has no oblique asymptote. All right, folks, so use this guideline here on page 203 to help you determine whether there's a horizontal or oblique asymptote. All right, folks, hope this is helpful as you're working in section 4.3.